let's just check how good you guys are at solving a basic trig equation. So when I teach trig equations, it's a 3-step process. And here are 2 example trig equations, or let's make 3. So sine x equals 0.7 would be one type of trig equation. Then another one could be cos x equals 0.3. And then maybe a 4th one that might be a little bit different would be like sine of x equals negative 0.2. So these are 3 trig equations, and often when they ask for the solution to trig equations, they either ask for it on a specific domain like 0 to 360, or they'll say find the general solution, which I say GS for general solution. Now, if I want to solve this first one, this is the way I teach it. And I think most of you have seen this before, but I'm going to go over it. Step 1, I ask, in what quadrants is sine of x positive? So tell me in the chat, where is sine of x positive? Which quadrants would that be in? Okay, so I can see from Jade and Seppo, we're going to be in quadrants 1 and 2. And what I say is that if you're in quadrant 1, then your answer will just be the reference angle. And if you're in quadrant 2, it will be 180 minus the reference angle. Okay, so that is quadrant 1 and 2's answers. But we haven't even spoken about this thing called the reference angle. To find the reference angle, I just write ref, and then I go shift sine or inverse sine, and then I go inverse sine of 0.7. And what do you get if you go inverse sine of 0.7? What is your answer going to be? You can pop it in the chats. So we are getting 44.42, it seems, from 2 students, 44.47. Can we have some others just to confirm? What are you getting when you go shift sine? 44.43. Okay. Yeah, okay. So that is my reference angle. Now, to get the answer to this final trig equation, there's actually going to be a step 3. And there's going to be a solution for quadrant 1 and a solution for quadrant number 2. In quadrant number 1, the answer is going to be just 44.43. But in quadrant 2, the answer is going to be 180 minus 44.43. So what is this answer going to be? 180 minus 44.43. We'll round off to 2 decimal places, yeah. So this is going to be 135.57. Okay, so our 2 answers are 44.43 or 135.57, but the sine function has a period. It repeats itself every so often. What is the period of the sine graph? Who knows what the period of the sine graph is? You can pop it in the chat. So the sine graph repeats itself every 360 degrees. So this solution will repeat itself every 360 degrees. And then we need to say, what is this thing called k? And k is just going to be an integer. So what does this actually do for us? Well, this is what's called the general solution. But if I need more solutions, I can go and generate more solutions. So in quadrant 1, if I let k be 1, so if I know k is 1, then another solution that is included would be 44.43 plus 1 times 360. And so another possible solution could be 404.43. If you put that into your calculator, sine of 404.43, you will get very, very close to 0.7. But they did not ask for any more solutions. So we just stay with this general solution here. Give me a thumbs up if you followed the 3-step process there and the logic. And give me a thumbs down if you didn't, and a meh, like middle smile or middle line if you're in the middle. Okay. So I will take questions from anyone who's unsure of anything, but I'd like the rest of us to try and do, we've done 1. I want you to try and do number 2 now. So the blue one, try and do that by yourself. And then I will take questions. If you put your hand up now, I'll take questions from students in the class. Yeah, I don't see any question hands at this stage. So we're going to go back to step 1 and ask ourselves, where is cos positive? What quadrants? So it's going to be quadrant 1 and quadrant 4. And in this angle, in this quadrant, it's that. And in this quadrant, it's just going to be 360 minus the reference angle. Oh. Okay, what is my reference angle going to be? 72.54. And that means my 2 solutions are going to be in quadrant 1 and quadrant 4. And I'll give you a bit more time to write that out. Okay. So as we look through this process, our final answers are going to be 72.54 and 287.46. If we put those values into the cos of x, we should get very close to 0.3. The only reason it's not exact is the rounding. And if I look at Jade agrees with me in the chat. Another question in the chat is, what is that k thing? The k thing is a placeholder for an integer. So k is an element of the set of numbers called the integers. And so normally you can think of k being 1 or -1 or 2 or -2. Saskia has asked, can you explain why the answers get a k times 360? So Saskia, that's got to do with the period of the sine graph. So if you think, or the cos graph. So if you imagine a normal cos graph, it starts at 1 and then goes like that, and like that. But then after that, it actually continues. It continues going. So if you imagine like this was 90, that was 180, that was 270, that was 360. If you wanted to visualize the answers that we got now, you would see that the answers we got were here and here. But if this graph carries on going, what's going to happen is it's going to come down again. Okay, so it's going to come down to here. Oh, and then it's going to go like that, and like that, and like that. Oh, that's not a very good drawing, is it? Like that. And so what's going to happen is there are going to be more solutions to my equation over here and over here. And the k times 360 basically gets us from here to here. That's 360. And then from here to here is going to be plus 360. So it's just giving you the other solutions if you need them. So Clemelo was asked about the Z, how should you write it? So Clemelo, this is the way you write it. So the Z is a Z with an extra line here. The K is a normal K. And then the element of is like an E that just faces the other way. Okay. Now, I want us to do the sine of X equals minus 0.2. But there's a sneaky difference. What's different about the red one? Who can tell me what's different about the red one? It's negative. So I'm actually going to add a fourth one here. I'm going to make this cos of X is minus 0.4, just so we get an experience of all the questions. I'm going to show you how to do the red one, and then you're going to do the green one. So you start off by asking, where is sine of X negative? Sine of X is negative here and here. Okay. In this quadrant, the format of your solution should be 180 plus the reference angle or 360 minus the reference angle. Give me a thumbs up if you followed me so far. There's nothing is new yet. The negative hasn't affected anything yet. Just let me know if you're following what I'm doing there while I clean the board. Okay, now here's where the thing comes in. In step 1, we have taken into account the fact that it is negative already. We do not need to take into account it is negative again, because if we do it twice, it's going to have the opposite effect. So what we normally do now is we find my reference angle, and we would find it by going inverse sine, but we do not use negative 0.2. What we use now is we use just 0.2 because we already dealt with the negative. We dealt with it over here by being in the correct quadrant. So this is the main mess up that students make. So what is my reference angle for this particular equation? So my reference angle, or in this case, it's going to be X, but we'll go, it's going to be 11.54. Okay, so now that we've done that, the last step says my answers must be in quadrant 3 or quadrant 4. I want you to work out for me what are my answers that go here and here, because I think that you guys can do that by yourselves. I don't want to steal your opportunity to learn. So see if you can figure out what comes next. What do you think is going to come next there? Oh, so this is going to be x is equal to 180 plus 11.54. And this is going to be x is equal to 360 minus 11.54. Let me see if I can move this down a bit. It's getting in the way. And so x should be 191.54, or x should be equal to 348.46. But I need to add something on. What do I need to add on still? There's going to be a k times what? K times 360, k times 360, and we say that k is an element of the integers. All right, let's just make sure we've completely got this waxed. I want everyone doing the green one, which is solve for me, find the general solution for cos of x equals minus 0.4. And I want you to do it solo mission. See if you can do that. Oh, what happened there? I think I've made it angry. Where is cos negative? I think it has to be quadrant here and here. I want to know what my reference angle is going to be. So in quadrant 2, x is going to be 180, or it's going to be Okay. Now, if I went a little bit quick there, I just want you to take a screenshot because it is a balancing act between making sure we have enough repetition and covering a nice variety. But yeah, and just give me a little indication, thumbs up if you're feeling good, thumbs down if you're feeling a bit like, whoa, 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 slow down, boy, there. Okay. Well, I feel like I haven't been giving tan the attention it deserves. So oh, Jade, you read my mind. You read my mind. So let us go and have a look at, where was my next one? Here we go. Okay. Now, before we start on a tan question, what I want to know is what is different about tan compared to sine and cos? Are there any differences that we need to know about? So Tsepo, Fazama, Klamelo have all said that tan's period is 180, not 360. So that's quite important. The other thing that's quite different is in step one, when we have to find the two quadrants that are relevant, when we deal with tan, because the period is 180, we only have to find one of the quadrants answers. So we don't need both quadrants answers with tan because the period is different. Okay, I'm not going to go into more detail on that at this stage, but this is the question I want us to tackle. Can you try and solve that trig equation using the methods you've learned so far today and only modifying the fact that the tan function has a period of 180, and so you only need an answer in one quadrant? And just see if you can do it. If you want to ask a question, feel free to do that, but I think you've got enough skill to do this now. And if not, we'll figure that out. So you would have to get that first step and get a tan of x is -5, where you isolate the tan x part. So where is tan going to be negative? Which quadrant? Yeah, it's going to have to be in quadrant 2. And we know that all angles in that quadrant are that. But now we need... Oh, okay. Fazama, very good question. If it was going to attach to x, they would have had to put a bracket around it like that. So very good question. In terms of the way it's written, it's a little bit ambiguous, but I agree that they should have been clearer. But if they wanted it to attach, if they wanted it to attach, they would have written it like that. But it is a little bit ambiguous, so I take your point. Good question. So what do we have here? We need to ignore the negative. And I just want to get my reference angle. So what's that going to be? Okay, so Fatejo says 78.69. Can anybody confirm? Cloto has also got 78.69. And so does Homelo. Okay. So then what is my final answer to this trig equation that is based around tan? Is it still going to be my final answer 78.69 or? Aha. So Jade, what you need to think about now is what quadrant is the solution going to be in? It's going to be in quadrant number 2. And remember I said for tan, you only need, even though tan would be negative in this quadrant as well, it's not wrong to do 2 solutions, but it's not necessary because of the period of 180, this is going to give us enough info to get that solution as well. So you're going to go x 180 minus 78.69, and that is going to give us 101.31. And then the difference is going to be that it's going to be k times not 360. I'm making a bit of a mess up there. It's going to be k times 180, where k is an element of the integers. So if you put 101.31, and you can try this into the tan of x, or the tan, you'll get very close to -5. All right, so in the first half of the lesson, what we have done is we've really got to grips with the method we're going to use to solve trig equations. Now, what's going to happen so how do we decide which quadrant to calculate? Clemedo, I normally just choose the smaller one, but either of them would have been correct. You could even do both if you have a lot of spare time, but there's no extra marks for doing that. So if you had used the fourth quadrant, 360 minus 78.69, that's also completely fine. So after the break, what we're going to start to do is we're going to start to look at slightly more complicated trig equations because we've got a good basic understanding of the method we use. And so before we do that, I know that your brains need, is it fine if we go back to the answer for cos of x equals minus 0.4? Josh, we could just take a screenshot for those who want the current screen. And then I'm going to go back for Josh in a moment. Boom, boom, boom. Cos of x, you wanted this one. So take a screenshot there, Josh, if you want. And then it's time for an exercise break. So you can start standing up in the interim for those who... And remember also, you can come back to the recording to pause the screen and look at it as well. Okay, so I want to see cameras on. I want to see all your wonderful faces, and I want to see you standing up with me. And yeah, just take a moment, stand up nice and tall, and let's breathe. So breathe in, we hold, breathe out, and so on. So 3, 2, 1. One more breath. Okay, now I want you to get nice and relaxed. So shake up your arms like they're licorice. You want them to be nice and floppy, whatever gets them nice and relaxed. Shake out your legs. You want them to be like, you don't want any pins and needles. You want circulation to be going. And yeah, do whatever relaxes your body. Okay, then let's do some basic shoulder rotations with small circles. And then we can do some big turns like we're doing the butterfly. Change direction and into smaller circles. Okay, then let's just do some basic rotations from our hips. Slowly at first. And as we relax, we'll find we are turning further. Yeah, then let's do some tricep. So 1, 2, 3, 4, 5. Other one. Yeah. And then some heart rate stuff. So we're going to do jumping jacks. We start in 3, 2, 1. Let's go. 2, 5, 6, 7, 8, 10, 13, 17, 18, 19, 20. Ooh, okay, so hopefully some blood and some oxygen are traveling around your body. Because of limited time, I'm not going to do Maths 24 today. I apologize to all our Maths 24 fans, but time is limited. And I think overall, oh, I can feel my heart rate. Overall, I think an extra example will be helpful today. So we're going to start with this question over here, the one I'm going to put in green. And I'm actually just going to write it bigger on the side here. While I'm writing it, what do you notice is different about this trig equation? So you can put your hand up or you can put it in the chat, but I want you to just take a moment to notice what is different about this trig equation. Who has some ideas? So 2 terms on the left-hand side. Yep. So there's the 2 and this. What do you think we're going to do first to solve this trig equation? What do you think my first step will be? Yeah, so the 2 on the other side, like all equations, you try to get the cos variable term by itself. So all I'm going to do is I'm going to take the 2 to the other side. It becomes a minus. And now I get this answer, well, I get this equivalent equation. Now, in the original question, they were wanting the solutions between minus 180 and plus 180. But for now, I'm just going to stay with the general solution. Now, what is different here is that no longer is there just an x inside, there's a 2x minus 10. But the good news is there's only one little thing we have to do differently to handle this. So what was our first step? It was to find where cos is positive. So where is cos going to be positive? Let me know in the chat where you think cos is going to be positive. So all I'm doing is I'm extending the methods I've taught you in the first part to handle more, I call them more dressed up trig equations. But once you get them back to the same dress code as before, everything is fine. So cos is positive in this quadrant in this one, which would be whatever the reference angle is, or 360 minus the reference angle. Okay, exactly the same as before. Second step is to find the reference angle. Now, the good news is we are just going to ignore the more complicated thing here. Normally, it's just x, but in this case, it's more complicated. Who cares for now? We just go reference angle, and we say inverse cos, and what do we get for that? Who can tell me my reference angle? So we are getting 57.52. Now, good news is we can go to step 3. What are the quadrants that are going to have my solutions? It's going to be quadrant number 1, and it's going to be quadrant number 4. Now, normally, when we go to this step, we would write x equals something. But because it was no longer just x inside the cos, what do you think I'm going to write to start over here? Am I going to write x, or what should I write instead? It's going to be 2x minus 10, because that is what is inside the cos function. And that is going to be equal to 57.52. Or we could say that 2x minus 10 equals, what could 2x minus 10 also equal? What could 2x minus 10 also equal? If we look at the method or process we've been following. Quadrant 1 was just 57.52, which was the reference angle. This would just be 360 minus 57.52. I want you to find me what is the value of x in quadrant 1 and what is the value of x in quadrant number 4. You have to do a bit more work. I suppose there would be an intermediate step where you go 67.52, and this would be 3760. That's going to be about 312, 313, something like that. Can someone just give me what is 360 minus 57.52 plus 10? I want to get 2x equals something, and I want it to be correct. That's going to be 312.48. Yeah. So we've got that. And then x is going to end up being, if we halve that. Now remember, we still have to include the general solution bit, but we should get 33.76, or x is 156.24. But if I want general solutions, the period, the period will be, now this is where I need to be careful. Oh, okay, hold on, wait. So what I need to do here is, okay, guys, I made a little bit of a mistake here. Let me include something here. Hold on. So what I need to do is, I should have done this at the very beginning. My apologies. So let me just reverse for a second. Everything is fine. So we had 2x minus 10 is equal to 57.52. So 57.52 plus, I should have gone k times 360 at that point. Or I should have written 2x minus 10 equals 360, okay, minus 57.52 plus k times 360. Now, if I don't do that, I'm going to end up making a silly mistake. Take a moment and see, do you understand the difference here? Do you understand the difference here between, you actually have to do it like this. You can't leave the k times 360 till later. You have to write this at the very beginning. So do you, give me a thumbs up if you followed me. Give me a thumbs down if you haven't followed me with this part. Okay, now, the reason you have to add this in now is that you need to divide the k times 360 by 2. So let's just keep going. So we go 2x equals 67.52 plus k times 360, or 2x equals 360 plus 10 minus 57.52 plus k times 360. And now let me just get this to be, what was this? This was 312.48 plus k times 360. And remember, we actually need to have k is an element of the integers here. Now, why is Mr. Skitter making such a fuss out of all the k times 360s throughout? Well, at this last step, when I divide by 2, okay, I'm then going to get 156.24. But I also have to divide the 360 by 2. How much do I get when I go 360 divided by 2? I'm going to get k times 180. And that's why I had to go back and make sure that I wrote this in at the very beginning. Okay. Now, with this one over here, on this side, I'm going to get x is, oh, sorry, guys, I made a mistake here. This should be 67.52 divided by 2 should be, let's have a look. What should that be? That should be 33.76. And then on this side, you should have, what is 312.48 divided by 2? It's going to be 156.24 plus k times 180, and that would be the correct answer. Okay, now, that was a bit of a toughie, so I just want to zoom out for a second. Are you all with me on that? Are there any questions or comments before I move on to our final example? Meh, don't worry, you can re-watch this for Techel. So, yeah, it's just a reminder that you need to put that K360 in here. Otherwise, if this is funky, that goes a bit bad. Okay, one more type of question I want to do today, and that is, let's do a quadratic one, and then we're going to call it a day for today. Okie dokie. So if we look at question 1, we're just going to do question 1. And we have to solve this trig equation. Why is this more difficult than the other ones? Why is this more difficult than the other ones? It's equal to 0, but I also think that it is the problem with the fact that there's so many things here. So what we need to do is we need to factorize it. Yes, Andile. So Andile, what would your factorization technique be for this one? Common factor, indeed. So you would take out the sine of A, and what would you then have inside the bracket for sine of A? So you've taken out the sine of A, what's going to be left behind inside? I think it has to be another sine of A minus the cos of A. Because if I multiplied that out, I would get back to that one. All right. Now, if you have a quadratic equation, you'll remember this from grade 9 or grade 10 even, you know that either of these things has to be 0. So this can split into 2 separate trig equations. Give me a thumbs up if you're okay with that. Give me a thumbs down if I lost you on that. So it just basically saying this one is, and it splits into its own two equations. Now, on this side, I don't think this is too difficult. This will go through our three-step process in a moment. But what should I do with this one? Now, there's a particular technique when you see sine A and cos A like this. I'm going to move the cos A to the other side, and I get sine A equals cos A. And then, and I'm running out of time, so I'm going to go through it with you. If I then divide both sides by cos A, what am I going to get below that? What's sine A over cos A? It's going to be tan A. Yep. And what is cos A divided by cos A the same as? It's going to be 1. So if we look at this equation, right? Common factor first step, split into two parts second step. Now you have to solve these two trig equations for me. So I want to give you a moment or two to do that. See if you can solve for the answers for this. So this is 0. So this could actually be in quadrant, as long as you get the pairs. So 0, you can actually just say here and here, or you could say here and here, because 0 is exactly on the line. So that's not going to be a problem. With tan being positive, tan would be positive in quadrant 1. What is my reference angle going to be for the sine of 0? It's going to be 0. And then in quadrant 1 and 2, A is going to be equal to 0 plus K times 360, or 180 minus 0 plus K times 360, where K is an element of the integers, which is really just saying, I'm running out of space here. So A is equal to 0 plus K times 360, or A is equal to 180. We just need to do one more part and then we're done. So tan is positive in quadrant number 1. So it's going to be here. What is my reference angle going to be? So Josh, with the tan trig equation, you can do 3 as well, but you only have to do one of them because the period is 180. So what is my reference angle here? It's going to be 45, yes. And so my final answer here would be A is 45 plus K times 180, where K is an element of the integers. So it's basically, you actually have 3 branches to your solution. But really what it's doing is it's repeating the stuff that you were learning earlier. The only bit that was a little bit spicy at the beginning was the top 2 lines here where we had to factorize it, and then we had to split into these 2 parts. And if you look at some past exams and you have a look, all that you need to be able to use are factorizing techniques. And then once you factorize, you split them into their pieces. Okay, I don't want to do more than that tonight. I feel like we're already pushing the limit of one lesson, but I do hope that you see how procedural trig equations are, and how the process, the only thing to watch out for is just that putting the general solution in at the beginning is helpful for forgetting to divide by that number.